Hey, AP Comp Sci Kids, Mr. Martin with a video for going through arrays. All right, so I'm just showing you the work that I did because some of the array stuff is honestly tricky, and I didn't want there to be a lot of dead silence as I was writing some stuff. So for one, we have a method called sum array. What I do sometimes is I create an array that has a particular amount of value so that we actually have something to go through. So we're trying to figure out which one of these we can use to replace the missing code so that the sum array method actually works. The correct answer is B, and we'll talk about why now. So imagine you create an array that has 5 values, 1, 2, 3, 4, and 5. The index positions are 0, 1, 2, 3, and 4 because arrays are always 0 indexed. So the for loop starts at I equals 1 and goes to the length of our array. And the example that we're going to use is going to go from 1 to 5 inclusive because of the equal, less than or equal to. So A simply doesn't work because it doesn't overwrite sum with the previous value of sum plus a new value. It only sets sum equal to the current value. And also key 0 is not accessible and key 5 is accessible, which would result in an out of bounds exception. Because if our loop starts at 1 and ends at 5, if you can access the actual length value of the array, you're always going to get an out of bounds error. So that alone will make A and E incorrect. Both of them present out of bounds exceptions. For B, it would actually be the correct answer because if we start at 1, you need to do I minus 1 to get the first value of the array, which would be key 0. So we're going to get, like for I equals 1, we get key 0. For I equals 2, we would get key 1. For I equals 3, we get key 2. For I equals 4, we get key 3. And for I equals 5, we get key 4. So even though our values take us past index values that our array can access, the I minus 1 gets us back into the array and it accesses 0 through 4. And because of the plus equals, it's going to mean that you take the previous value of sum, add it to the value that's in key I minus 1, and then save that value as sum. C won't work because it's an out of bounds exception because I starts at 1. If our array started at 0, if the loop started at 0 and went to key dot length not inclusive, C would be the correct answer. And more importantly, C is generally how we write our arrays. D doesn't work because what it's going to do is add sum in key and then add the other value of sum and replace sum with that. So we've added the value of sum 1 too many times. So again, B is the correct answer. For 2 is the trickiest one in the packet. Only 1 is correct. And the reason being is that, again, if you create an array, I created one that has 6 values this time. Non-decreasing means that the value to the right is always equal to or greater than the previous value. So this array that I crossed out is it is decreasing because between the 4th and 5th term, you go down, like the 4th and 5th term, the 5th term is less than the 4th term. So that just won't work. So our loop starts with k equals 1 and goes to data length dot 6. Now again, for data dot length, which is 6. So for me, if you create an array that has 6 values, could be 5, it doesn't really matter. If we create an array that is non-decreasing, we need to check if this works. So now, if the previous value is more than the value to its right, you should return false or then return true. So the reason this works is that even though k starts at 1, again, the k minus 1 is going to give us, if k equals 1, you're going to have if data 0 is greater than data 1, and so forth until we get to k equals 5 is this last value that this loop would run for. So if data 4 is greater than data 5. So this number 1 works as intended. 2 does not work because we get an out of bounds exception for k equals 6, because if you go from 0 to 6 is going to be the cutoff point, but 5 is going to be included. So if we had data 5 greater than data 6, that's not going to work because data 6, there's no index value for that. You, again, can't access something that the array doesn't have. So 2 doesn't work for, because we get an out of bounds exception. For 3, all right, so 3 is tricky, right? Because we have k equals 0 to 5. So that's going to give us, even with the +1, it gives us 0, 1, 1, 2, 2, 3, 3, 4, 4, 5. And the last value of 5, k is going to be 5. So then here we're going to have 5. And, actually, the last value that we're going to have is 4. So k is going to be 4 and then 5. So reasonably, it seems like this works because you don't get an out of bounds exception and you check each value compared to the value to its right. So seemingly this should work. The problem is this return, this else statement inside the loop. This is going to result in this part never executing, because if this is false, if say this doesn't turn out to be true, if this statement is true, you're going to return false that the array is not sorted. Otherwise, you're going to return true. So you never have to go back and increment k by 1. And it's very subtle. Now, if you were typing this into Eclipse, which I do encourage you to do for all the examples, you would get an exception that says something like dead code or something. I'm not sure if it would print a red error. The yellow errors mean that generally you get like some sort of dead code. But if you type this into Eclipse, you should get a dead code because this statement prevents this loop from continuing to run, which means that this won't ever execute. The loop will check the first reasonably it'll try to check, but this won't work. So you never get here, and then this is going to be redundant. So 3 doesn't work because you can't actually increment the loop. So the only one that actually works is 1. For 3, it's pretty simple. We have a method called count target, and you're basically counting the number of times a particular value shows up in an array. And the only problem is that where this is less than or equal, because it's array.length and we start at 0, you're just going to get an out of bounds exception because j can't equal array.length. Or, I mean, it can, but then this needs to be j minus 1, and that needs to start at 1, for instance. But because we start at 0 and you have to go up to the array length without including that, the change should just be that this should just be less than. And so that's going to make B the correct answer. For number 4, it's actually exactly the same thing. You want to change the less than or equal to just less than, so that, again, because you're starting at 0, you want to end at, in this case, 0, 1, 2, 3, 4, 5. You want to go up to array.length, which is 6, but just not inclusive, or r.length, which is not inclusive. For number 5, you have an array that contains values 1 through 7, and we have a loop that's going to start at I equals 1 and skip the even numbers essentially, and the array position, for instance, like 1 is going to equal array 0. So I went through the trouble of showing you that this is only going to run for I equals 1, 3, 5, and 7. So in our, this is only going to run for values I equals 1, 3, 5, and 7. So when I equals 1, array value 1 is going to equal array value 0. So that means that we have 0, 1, 2, 3, 4, 5, 6. So array value 1 is going to equal to array value 0. So that means that it needs to be 1. Array value 3 is going to equal array value 2. So 0, 1, 2, 3. So 3 is going to equal 2. So we get 3. And array value 5 is going to equal array value 4, actually. So 0, 1, 2, 3, 4. So this value is going to equal that. So we get 5. So C is the correct answer because we get 1, 1, 3, 3, 5, 5, and 7. Now, again, we skip by 2. So that's something to pay attention to, that we are skipping all of the even numbers in our index value, so we don't change those at all. And so because 7 exceeds the length of the array, you don't actually change that last value. For number 6, you have this segment, you have a loop that is to change the value of minimum array by using the value of array 1. And all right, so if we look at this, C equals 0 and you go to array 1.length. If array 1 for a particular value is less than min array for that same thing, you want to, what we actually want is that this value should go into the minimum array. And what this is going to say is that the array value equals minimum array, but that value isn't in the minimum array. Array 1 should remain unchanged. So what needs to happen is you need to just delete lines 5 through 8. Now, the reason D could work if you weren't to change, like if array 1 didn't have to remain unchanged, but since array 1 should remain unchanged, D can't be correct, and C would be correct because you want to take the smaller value and then update minimum array with that value. So that means that you don't need 5, 6, 7, or 8. You just need this part, and there's no else because nothing else needs to change. Now, if you wanted to just swap the values, we need a temporary value to store that, and then update array 1 with the other value. But we're not swapping, we're literally just replacing. So only C should work. Changing this to less than or equal to array 1.length, that's going to result in an out of bounds exception, so that's not going to work. And changing the relational operator to greater than in line 3, that's still not gonna, like, reasonably it could work, but you're still not changing the value in minimum array. You would have to do that and something different. So B doesn't work either. For number 7, what we have is an array of Boolean values. So old values is true, false, true, true, and new values is an array of 4 values, and the array starts at the end. The loop starts at the end, so we're going to go from position 3 to position 2 to position 1 to position 0, and the values in the new array are going to equal the opposite of the values in the old array. So what's going to be stored here is, even though it's going in reverse order, the array still is going to contain in order the opposites of these. So that's going to be false, true, false, false. So C is the correct answer. They're trying to get you with D by doing the way you would take these in, which would be false, false, true, false. But this is in reverse. D is in reverse order. So don't be fooled by that. For number 8, for 1, all right, so we're trying to see which one of these will print the same thing. We have an array declared that has 1, 2, 4, 0, and 3. We have an enhanced for loop. Remember, for an enhanced for loop, I refers to the array value, not the array position. So what this would print is 1, 2, 4, 0, and 3. 1 doesn't work because it's the wrong syntax for an enhanced for loop. This should just print I, which would again be redundant because it would be exactly the code segment that we start with. So you don't need 1. For 2, you have 1, 2, 4, 0, 3. I starts at 0, goes to the length of the array, incremented by 1, but then you print the value of I. This is going to be the index. I did index. I spelled index backwards, so index. So this would print 0, 1, 2, 3, and 4. So 2 also doesn't work. So the only one that actually works is 3, because to print the actual array value, you have to reference the array and give it an index. So this for loop does that. I starts at 0, ends at 4, so it's going to print R1, R2, R0, R1, R2, R3, and R4, which would be the same as this. So only 3 works. And finally, for number 9, we have an array that contains 3, 1, 0, 4, and 2. And for each value, you're going to take the array, the actual value at the index value, and add the index value and include a space. So array 0 is going to be 3 plus the index value, which is 0, which is still going to be 3. Array 1 is going to be 1 plus the actual value at 1, which is 1, plus the index value, which is 1, which is going to be 2. Array 2 is going to be the value at index position 2 plus 2. So that's going to be 0 plus 2, which is 2. Array 3 is going to be the value at position 3, which is 4, plus the actual index value, which is 3. So 4 plus 3 is 7. And then array 4 is going to be the value that is there, which is 2, plus the index position, which is 4, which is going to give us 6. So B is the correct answer. So hopefully this is helpful. If not, talk to me in class before we take the quiz. See you guys later.